Okay, welcome back to part two of the video. Mr. Choi here. So in the previous video, what we have learned is that we have now learned how to describe motion using graph. There are two types of graph, velocity time and displacement time. And we have also learned that from these two graphs, we can obtain acceleration, for example, from the gradient of the VT graph. And there's one thing new. If you want to find the distance or displacement, and the speed or velocity is no longer constant, you have to rely on a VT graph and you have to find the area underneath, and that area will give you the displacement traveled, okay, when the object is moving at changing speed. We have also learned that from the displacement time graph, we can find the speed or velocity of the object through its gradient. So that's what we have learned in the previous video. In this video, we are going to focus on describing motion using words. And we can describe motion mainly by two parameters, the velocity and acceleration. And we will need to add an adjective in front of these two parameters. So there are only four of them. Velocity, obviously there will be v0. There can be increasing velocity, decreasing velocity, or constant velocity. And similarly, for acceleration, we have the four adjectives as well. A is 0, increasing A, decreasing A, constant A. So I will be giving you a very rough idea of what this means, especially decreasing A, because a lot of students tend to confuse decreasing acceleration with deceleration. So actually these two concepts, deceleration and decreasing acceleration, they are different. They are completely different. So what I'm going to do is that I'm going to share with you one approach first on what they mean. So for example, if I were to have a car A with acceleration equals to 0, what does it mean to the velocity? So the V here represent the velocity of car A. So if I have acceleration equals to 0, essentially it means that because acceleration refers to the change in velocity over time, right? So if there is no acceleration, effectively it means that there is no change over here, right? So A equals to 0, in another word, is the same as constant V lah. So if I have A equals to 0, what it means to my car A maybe at time equals to 0, if the V is 4, it means that the velocity will not change. This is the meaning of A equals to 0. So A equals to 0, does it mean that the object is at rest? No, the object is moving because it has a velocity. Okay, so remember A equals to 0, it is not the same as V equals to 0. In fact, when V equals to 0, A can be other number. Okay, it need not be V is 0 doesn't mean that A is 0. Okay, let's say in another setting, let's say I have a car B, and car B is moving at increasing acceleration. What does it mean in terms of the velocity? Well, what it means is that if car B at time equals to 0, the velocity is 4, then because there's acceleration, right, it means that the velocity will rise. So let's say it rises to 5. And then in the next instance, it will rise again. But this time round, the rise is way more, right? Then after that, in the next instance, it will rise again. The velocity will still rise because it is acceleration, right? Because it is increasing acceleration. Acceleration means it speed up. So the velocity will continue to rise. Maybe this time around is 25. So what's the difference between a normal acceleration versus increasing acceleration? Well, in this case, you can notice that the jump here is +1, the jump here is +5, and the jump here is +15. You can see that the change in velocity is actually getting larger and larger. This is the meaning of increasing acceleration. Yeah. How about decreasing acceleration? If now I have decreasing acceleration, and I want to ask myself, is it the same as deceleration? Well, let's look at this first. Decreasing acceleration. So since the word acceleration is used, it means that the magnitude of the velocity must be getting bigger and bigger. That's why it is acceleration. So what does it mean by decreasing acceleration? Well, it means quite straightforward. Maybe it is a 4, then it rises to 24, then maybe it rises to 34, then maybe it rises to 40. You can see that the velocity if is keep on getting bigger and bigger, so that's why it is acceleration. So what does it mean by decreasing acceleration? Well, you can notice that the change at the beginning is plus 20, then after that is plus 10, and finally it's just plus 6. You will notice that the change over here is getting smaller and smaller. This is the meaning of decreasing acceleration. And it is very different from deceleration, right? Because if it is a deceleration case, then the velocity will be changing from maybe 100 to 90 to 80 to 70. You can see that the V actually get lesser and lesser. So there's a difference between deceleration and decreasing acceleration. The main difference is deceleration, it is slowing down. Decreasing acceleration, the object is still speeding up, but it is speeding up at a slower rate. Okay, and of course lastly we have the last type of acceleration, which is when the acceleration is constant. So if the acceleration is constant, then it is quite straightforward. It will be like 4, 14, 24, 34. You can see that the jump over here, it is constant. So this is what it means by constant A. So that this is the meaning of these 4 types of acceleration. Okay, so now what is the next step? The next step is that now that we know how to describe motion using words, we are going to link what we have learned in graph together with what we have learned in words. So what I'm going to do is that I'm going to give you a series of graph, and you are supposed to tell me the types of motion that is being described by the graph. So these first four are displacement time graph. So in this case, it is written here distance time graph. It is fine. Positive distance and positive displacement are the same, right? Because essentially displacement is just the vector counterpart of distance, right? So here let's look at the first graph. Before we go into the questions, just have a quick recall. If it is this distance time graph, what we can obtain from the graph is that we can read from the gradient, and that will tell us the speed. So if now I look at this particular distance time graph, what can you say about its gradient? Well, the gradient here is 0, right? So in another word, the speed is 0. So meaning what? Meaning that the object is at rest, right? The object is at rest. What is being described by the distance time graph is that the object is at rest, right? How about this graph? Well, again, you can see that I will be using the same approach to actually describe the motion from a graphical form to a verbal form. So how would you describe the gradient here? Well, the gradient here is constant, right? Because it is a straight line. So what does the gradient of a this distance time graph represent? It represents the speed. So we say that the speed is constant, right? So here I will just write down that it is moving at constant speed, right? Yeah, I can also write this as constant velocity because positive speed is the same as positive velocity, right? So I can use it. I can claim that it is constant velocity as well. How about the third graph? Well, it is still a distance time graph, so I'm going to use the same approach, right? I'm going to ask myself, how am I going to describe the gradient? So down here, this is a curve, and you can see that, let's say I compare this point. This is the gradient of the tangent, and then if I compare this point, you can see that the gradient of the tangent actually getting steeper, right? This is steep, right? This is quite gentle, right? So in this case, if you recall in your mathematics, we call this increasing gradient, right? Because the slope become more and more steep. So since the gradient represents the speed of the object, then what this graph is describing is that the object is moving at increasing speed. That's all. Right? In another word, it is accelerating. Right? That there is acceleration. Correct or not? Yeah. We can also do the same thing over here. If the speed is constant, what can you say about its acceleration? Well, constant speed means that there's no change in speed, right? If there's no change in speed, it means that my acceleration will be equals to 0 lor, right? So we can actually look at the distance time graph, and by looking at the gradient, we can deduce the velocity or the speed of the object, and then we can further deduce the type of acceleration that we are seeing. How about this one? How would you describe the gradient? So if you look at the beginning of the graph, you can see that this is the gradient of the tangent, and then towards the end, the gradient of the tangent is like that. So you can see that at the beginning, the gradient of this tangent is steep, but then as it go along the time axis, it become more gentle, right? So in this case, in mathematics, this is what we call a decreasing gradient. So since the gradient of a distant time graph represents speed, we can also say that this is decreasing speed, right? So I can say that, oh, the object is moving with decreasing speed, and if the speed decreases, it means that there is deceleration. Now, some of you may be asking me, in this case, do I know the type of acceleration or deceleration? Do I need to say that it is constant, it is increasing or decreasing? Well, for a distant time graph, we can't tell the type of acceleration just by looking like that. We will need to do some calculation, right? What kind of calculation do we need? Well, what we can do is that we can actually, looking at the table values here, we can actually come up with a row that actually measure the velocity or the speed, right? And then from the value of the speed, we can deduce whether this deceleration is increasing or decreasing, but let's not do it here. It's too much work, right? So this is how you describe motion from a distant time graph or displacement time graph. Yeah. Next, how about a speed time graph? So in this case, since the speed we are dealing with is all positive, it is the same as a velocity time graph, okay? As long as the speed is positive, it is the same as its velocity, right? So we can call it with different names, okay? So first graph, you can see that the speed is 0 throughout. At all the different time, the speed is 0. So what does this mean? Well, yeah, it means that the object over here is at rest, right? Because the speed is 0, correct or not? The velocity or the speed is 0. How about in this case? Well, the speed is 10 at time 0. The speed is 10 at time is 1. The speed is 10 at time is 2. The speed is 10 at time is 3. So how do we call this? What kind of speed we are talking about? What is the adjective that we should use? Constant, 0, increasing, or decreasing? Oh, yeah, the object is moving at constant speed lor. And what kind of acceleration we are talking about if the speed is constant? Well, this is speed time graph. So in speed time graph, if you go back up on top here, in a speed time graph, the gradient actually represents the acceleration, right? So actually for a velocity time graph or speed time graph, if you want to describe the type of acceleration, you can do the same thing by analyzing its gradient. So in this case, the gradient is 0. So what can you say about the acceleration? It is 0 as well, lor, right? So it had 0 acceleration. Simple, right? Yeah. Okay, then after that, let's look at this graph. Yeah, what can you say about its speed first? Its speed. Is the speed 0, constant, increasing, or decreasing? So in this case, let's look at time is 0, speed is 0, time is 1, speed is about 5, time is 2, speed is about, I don't know, 8, time is 3, speed is 12. So we can say that the speed is increasing. How about its acceleration? So we look at the gradient, no? Right? So here the gradient is constant, so we say that the acceleration is constant as well, right? Yeah, and in exam, if they require you to give more detail, you can even calculate what is the acceleration here, right? We can calculate the gradient, yeah. Okay, how about this one? What can you say about its speed? 0, constant, increasing, or decreasing? Well, at the very beginning, the speed is 20. At time equals to 1, it becomes 16. At time equals to 2, it becomes 12. So what kind of speed? It's dropping, right? So therefore, it is decreasing speed. How about in terms of acceleration, right? So down here, you can say that the gradient here is constant. And at the same time, you also notice that the gradient here is negative, right? So what does this mean? Well, this means that my acceleration is negative. And since we are talking about positive velocity, it means that now we shouldn't be calling this an acceleration. It should be called deceleration, right? Because it's slowing down, right? And what type of deceleration? Well, the type of deceleration is that it is constant, no? Correct or not? Yeah, so down here is a bit more tricky. Yeah, so decreasing speed at constant, not acceleration but deceleration, right? Because it's slowing down. Yeah. Okay, how about the last two? It is a curve. So let's talk about the speed first. So what kind of speed? Increasing, decreasing, 0, or constant? Well, at the time equals to 0, speed is 0. At time is 5, the speed has rise to 20. So definitely it is increasing speed, right? How about its acceleration? Well, to tell the acceleration, I need to look at the gradient, right? So in this time, if you look at the math, what kind of gradient we are talking about? Is it an increasing, decreasing, or constant gradient? Yeah, so I hope now you can see without me giving you a hint that the gradient of the tangent actually gets steeper. So we say that this type of gradient is increasing gradient. So in another word, the acceleration that is showing here is the increasing type, right? So we say that the acceleration is increasing. Yeah, how about this one? Let's talk about the speed first. Is it increasing, decreasing, 0, or constant? So at time is 0, speed is 0, time is 5, speed become 20. So what kind of speed? Increasing, right? It become larger. Yeah, and in this case, what kind of acceleration are we talking about? So you look at the gradient, right? And I hope you can see that now that the gradient is decreasing. So therefore, the type of acceleration that we are talking about is decreasing acceleration. Right, so you can see there are different types of graph, right? And in O-level, all these different type of graph can come together and form a more complex speed time graph. And in O-level, they will ask you, can you describe the motion, right? On each section of the graph, like OA, how does it move? Okay, so now I want you to use your SLS and key in your answer. Okay, after you key in your answer, you can actually check whether your understanding is correct. But before that, let me highlight to you. between G and H, this is straight line. Okay, because some of you on your printout, it looks like it is a curve. Okay, between OA, it is also a straight line. BC is also a straight line. Okay, yeah. Okay, have fun.